Hey everyone, this is your instructor from Wealth Concept 365. In this lesson, we're going to go over IP addressing and subnetting. We'll go over some of the basics here, including what an IP address is, how they're structured, how subnetting works, how to subnet an IP address, how to calculate the subnet mask, subnet addresses, and also the default gateway and host addresses. So let's get started with the lesson. Okay, so before we actually start talking about subnetting, let's talk about what an IP address is. An IP address is like a unique name or address for your device. It's how your computer or network device communicates with other computers on the network. Now there are two types of IP addresses. You have IPv4, which is the older version, and we're going to be focusing on in this lesson. And then you also have IPv6, which is the newer version. But again, we're going to focus on IPv4. So how does an IP address work? Well, basically, when you try to visit a website such as Google.com, a signal goes out to your router, and your router takes that signal and sends it to another router, which sends it to another router until it eventually reaches the final destination, which is the server at Google that has the website that you requested. How do all these routers know where to send the signal? They use things called IP addresses to figure that out. So each router and computer has a unique IP address. So when the signal goes out from your computer to your router, the router knows where to send it because it knows the IP address of the next router, and the next router knows where to send it because it knows the IP address of the next router, and so on and so forth until it eventually reaches the final destination. Alright, so let's take a look at how an IP address is actually structured. Okay, so here we have an example IP address 192.168.1.200. So you can see that it's divided by these dots, and these divided into 4 sections, and each section can be from 0 to 255. Also keep in mind that each section can also be represented by a hexadecimal value. So, for example, 192 could also be represented as CO. Why is that? Well, if you take a look at your calculator, you can see that CO in hexadecimal is actually 192 in decimal. So both of these values are equivalent. Now, why is this important? Well, let's go ahead and take a look at this chart. Take a look at this chart. It's called a subnet mask calculator. You can find a link to this website down below. But essentially what it does is it shows you the range of IP addresses based on the subnet mask. So let's say, for example, I enter in 255, 255, 255, 0. When I click on Calculate, it's gonna tell me that the range is from 255, 255, 255, 0 to 255, 255, 255, 255. So the first thing I could do is I could change this value from 255 to CO and the second one from 0 to 0, and then click on Calculate. And then I would get the same results. I would get the range from CO 0, 0, 0 to CO 0, 0, 255. What I can also do is I can set the first value to 192 and the second one to 0, and then calculate, and I am gonna get the exact same thing. And then I can convert the third one to CO and the fourth one to FF, and then click on Calculate, and I am gonna get the exact same thing. So basically, you can use either the decimal values, or you can use the hexadecimal values. However, in networking it's more common to use the hexadecimal values instead of the decimal values, but again, both of them are equivalent and they both mean the same thing. Now let's move on and talk about what a subnet mask is. A subnet mask is what allows us to divide the IP address into 2 different sections. One section is called the network portion, and the other section is called the host portion. So what we do is we take the IP address and we take the subnet mask and we perform a bitwise AND operation between the two. And whatever comes out, we call that the network address. So the network address is essentially the network portion of the IP address. Then we take the IP address and we perform a bitwise XOR operation with the subnet mask. And whatever comes out of that operation, we call that the host address. So the host address is essentially the host portion of the IP address. Let's take a look at a practical example. So here we have a network address of 192.168.1.0, and we have a subnet mask of 255.255.255.0. So let's go ahead and do the bitwise AND operation. So we have 192.168.1.0, then we have 255.255.255.0. If we perform a bitwise AND operation, we're going to end up with 192.168.1.0. So this is our network address. And then if we perform a bitwise XOR operation, we're gonna end up with 64.32.1.0, and this is our host address. Now remember that this is just one example. There's actually a whole range of possible host addresses. Let me show you what I mean. So here's the network address of 192.168.1.0, and here's a subnet mask of 255.255.255.0. Again, if I perform the bitwise AND operation, I end up with the network address of 192.168.1.0. If I perform a bitwise XOR operation, I end up with 64.32.1.0. But if I were to change this to 192.168.1.1, then my host address would become 64.32.1.1. If I change this to 192.168.1.2, then my host address would become 64.32.1.2, and so on and so forth, all the way to 192.168.1.254. Any of these values are possible host addresses. Now, I'm sure that you're probably wondering how many possible host addresses there are. And the way that you calculate that is you simply take the subnet mask, you convert it to binary, you count the number of ones south, and then you subtract that from 32. That's going to give you the number of possible host addresses. So, for example, if we take the subnet mask of 255.255.255.0 and we convert it to binary, we're gonna get 11,111,111.000, and if we count the number of ones, we see that there are 8 ones. So we take 30 to minus 8, which gives us 24, so we could have to 2 the 24th power, which is 16,777,214 host addresses. Or if we took the subnet mask of 255.255.255.128 and we converted it to binary, we would get 11,111,111.0. 10 million. And if we counted the number of ones, we see that there are 9 ones. So 30 to 9 equals 23. So in this case, we would have to 2 the 23rd power, or 608 possible host addresses. Okay, now let's talk about what a subnet is. Essentially, a subnet is a logical division of a network. Just like the IP address divides into the network portion and the host portion, a subnet further divides the network portion into smaller networks. And the way that you do this is with something called a subnet mask. So let's take a look at this. We have a network address of 192.168.1.0, and we have a subnet mask of 255.255.255.0. Now, if we wanted to subnet this into two different subnets, we would take the last octet of the subnet mask and we would divide it into two different values. So let's say, for example, we divide it into 128 and 0. What this is gonna do is it's gonna allow us to have two different subnets. So here we have a network address of 192, 168, 10, and a subnet mask of 255, 255, 255, 128. If we performed the bitwise AND operation, we would end up with the network address of 192, 168, 10, and then if we were to perform a bitwise XOR operation, we would end up with 64, 32, 128. So these two addresses are our two different subnets. Let's take a look at another example. So here we have a network address of 192, 168, 10, and a subnet mask of 255, 255, 255, 128. If we wanted to further subnet this into four different subnets, we would take the fourth octet of the subnet mask and divide it into four different values. So let's say, for example, we divide it into 192, 168, 128. Then, if we performed the bitwise AND operation, we would end up with the network address of 192, 168, 10, and then if we performed a bitwise XOR operation, we would end up with 64, 32, 10. So these are our four different subnets. Okay, so now that we know what a subnet is, let's go ahead and take a look at how to subnet an IP address. So here we have an IP address of 192, 168, 150, and a subnet mask of 255, 255, 255, 0. The first thing that we want to do is convert both the IP address and the subnet mask into binary. So if we convert 192, 168, 150 to binary, we're going to get this. And if we convert 255, 255, 255, 0 to binary, we're going to get this. Next, we want to take the network portion of the IP address and perform a bitwise AND operation with the subnet mask. And whatever comes out, we call that the network address. So, if we perform a bitwise AND operation between these two, we get 11,10,101,000. 0. Converting this back to decimal, we end up with 192, 168, 0. So this is our network address. Next, we want to take the entire IP address and perform a bitwise XOR operation with the subnet mask. And whatever comes out of that operation, we call that the host address. So if we perform a bitwise XOR operation between these two, we end up with 0111111, 11,011,011, 11,111,111, 11,111,100. Converting this back to decimal, we end up with 64, 32, 144. So this is our host address. Now that we know the network address and the host address, we can find out how many possible network addresses there are and how many possible host addresses there are. So to find the number of possible network addresses, we take the subnet mask, we convert it to binary, we count the number of 1 south, and then we subtract that from 32. So if we take the subnet mask of 255, 255, 255, 0, and we convert it to binary, we get 11,111,111. 0. And if we count the number of ones, we see that there are 8 ones. So 32A equals 24. So this means that we have to 2 the 24th power, or 16, 777, 214 possible network addresses. To find the number of possible host addresses, we take the IP address, we convert it to binary, we count the number of ones, and then we subtract that from 32. So if we take the IP address of 192, 168, 150, and convert it to binary, we get 11,010,101,000. 10,011,100. And if we count the number of ones, we see that there are 8 ones. So 32A equals 24. So this means that we have to 2 the 24th power, or 16, 777, 214 possible host addresses. Okay, so now that we know the network address and the host address, let's find out what the default gateway address is. So remember that the default gateway is the router that connects your local network to the internet. So the default gateway address is simply the network address plus 1. So the network address is 192, 168, 0, 0, and 192, 168, 0, 0. 1 is the default gateway address. And finally, let's talk about what the broadcast address is. The broadcast address is used for certain special type of network communications. The broadcast address is simply the network address with all O south replaced with 1 south. So the network address is 192, 168, 0, 0, and if we replace all the O south with 1 south, we get 192, 168, 255, 255. So this is the broadcast address. Alright, so let's take a quick break and come back and continue the lesson. Okay, so far in this lesson we've gone over what an IP address is, what the subnet mask is, what a subnet is, how to subnet an IP address, how to calculate the number of possible network addresses and host addresses, what the default gateway is, and what the broadcast address is. Now let's go ahead and take a look at a few practice questions. Question No. 1. What is the network portion of the IP address 192, 168, 200? Well, if we take a look at our example IP address earlier, we saw that the network portion was 192, 168, 0. So the answer is 192, 168, 0. Question No. 2. What is the host portion of the IP address 192, 168, 200? Well, we saw that the host portion was 64, 32, 200. So the answer is 64, 32, 200. Question No. 3. What is the network address of 192, 168, 100 with a subnet mask of 255, 255, 255, 128? Well, let's go ahead and perform the bitwise AND operation. So 192, 168, 100, 255, 255, 255, 128. If we perform a bitwise AND operation, we get 192, 168, 0. So the answer is 192, 168, 0. Question No. 4. What is the host address of 192, 168, 100 with a subnet mask of 255, 255, 255, 128? Well, let's go ahead and perform the bitwise XOR operation. So 192, 168, 100, 255, 255, 255, 128. If we perform a bitwise XOR operation, we get 64, 32, 1, 128. So the answer is 64, 32, 1, 128. Question no. 5. How many possible host addresses are there with a subnet mask of 255, 255, 255?